Welcome to the deep dive. If you're anything like us, you've probably felt the whiplash lately from the constant stream of new AI models dropping. It can be hard to tell what's just hype and what's genuinely impactful.
Oh, absolutely. Every week, something new.
Exactly. But every now and then, a model lands that just feels different, a real challenger. Our source material describes today's deep dive subject, Kimi K2, as something that landed on a workstation, like a friendly but determined raccoon.
Huh. I love that description. A raccoon.
Right. It really sticks.
Yeah.
Suggests it's tenacious, maybe a bit disruptive, ready to get its paws dirty in your workflows. So our mission today is basically to unpack the real-world performance, the surprising capabilities of Kimi K2, especially comparing it to Llama 3. We want to help you, our listener, cut through the noise, get truly informed, quickly and thoroughly about this intriguing new player in open source AI.
And it really is intriguing. At its core, Kimi K2 is what the source calls a mixture of experts, or MOE, monster.
MOE monster.
Yeah, developed by Moonshot AI. And when we say monster, we mean it. Imagine not just one big brain, but 384 specialized experts.
384. Wow.
Right. And for every piece of information, every token, Kimi K2 smartly activates just two of those experts. So it means it has this astonishing 1 trillion parameters on disk.
A trillion.
Yeah. But here's the clever part. Only about 32 billion parameters are active per token. So it's incredibly efficient for its size.
Okay, so massive potential, but efficient in practice.
Exactly. And Moonshot AI's pitch is pretty straightforward. Make agentic AI practical, keep the license open, price it like commodity cloud storage, and crucially, beat Llama 3 on every leaderboard that actually matters to developers.
Okay, that MOE monster description definitely hints at something special. So let's unpack the architecture. How does Kimi K2 actually achieve this status? What are the key design choices making it stand out?
Well, the real ingenuity seems to be in Kimi K2's design philosophy. It's like, use brute force capacity where it helps, but be thrifty where it doesn't.
Yeah.
The goal, as the source puts it, is squeezing more intelligence per watt than any other open source AI model of comparable size.
More intelligence per watt. I like that.
Yeah, and specifically, that mixture of experts, routing choosing just 2 out of 384 experts per token, that's the clever trick.
Yeah.
It keeps the compute needs roughly, GPT-3 size,
Okay.
while pushing its overall capacity and knowledge into GPT-4 territory.
That's quite a balance.
It is. And another highlight is this muon clip optimizer.
MuClip. Tell me about that.
So think of an optimizer as the engine helping the model learn efficiently, consistently. Muon clip cleverly clips certain internal values during training. It basically prevents what they call attention logits from exploding, stops the model's internal math from becoming unstable, going off the rails.
So it keeps the training smooth.
Very smooth. It resulted in, and this is incredible, 0 gradient spikes across a 15.5 trillion token pre-training replay.
15 trillion tokens. 0 spikes.
0 spikes, meaning much more reliable, stable learning over just vast amounts of data.
Okay, that's impressive stability. What else?
And finally, it's token and positional encoding. They're tuned for a massive 128K context window.
128,000 tokens.
Which means, and this is a direct quote, you can feed an entire software repository on one side and a 300-page spec on the other.
Okay, that's practical. That's something developers can really use.
Exactly. Really useful for those big, real-world tasks where context is key.
So architecturally clever, built for stability, massive context.
Got it.
But the real test, obviously, is performance. How does all this translate into benchmarks, especially those tough engineering task developers like you care about? This is where it gets really interesting, right?
Absolutely. And these benchmarks, they aren't just numbers. They really seem to reveal Kimi K2's strategic advantage. It's not just generating code. It's like solving engineering problems.
Okay, how so?
The data shows it consistently beating Llama 3 on coding tasks, often by double-digit margins. Okay, so live code bench V6 pass at 1. Kimi K2 gets 53.7%. Llama 3 is at 48.5.
Decent gap.
Yeah. And HumanEval pass at 1. Kimi K2 hits 85.7% against Llama 3's 81.7.
Still ahead.
But here's where it gets really stark. Agentic tasks, complex stuff.
Right, the problem-solving part.
Exactly. On SWE-bench, verified that measures reading failing tests, drafting a patch, committing working code, first try.
Okay, a realistic workflow.
Very realistic. Kimi K2 looks, quote, twice as competent. It scores 65.8% compared to Llama 3's 38.8%.
Wow, that's That's a huge difference, almost double.
It's massive. And for general reasoning, MMLU, it gets 89.5.
Which puts it where, roughly?
The source says that's near GPT-4 class performance. Pretty amazing for an open source model.
Near GPT-4, okay. And math?
Math is another big one, a dramatic lead. 97.4% accuracy on Math 500 for Kimi K2, Llama 3, 50.4%.
97 versus 50. Good grief.
Yeah. So zooming out what this all means, Kimi K2 seems poised to sit at or very near the top for basically any open source LLM leaderboard that doesn't need vision.
Okay, those are some seriously impressive numbers, especially on the agentic and math side. But, for real-world use, price changes everything.
Yeah.
What about the ownership economics, as the source calls it? Is this power actually affordable for you, the listener?
Right, that's the critical question, isn't it? Can an open source model really compete on both price and performance against the big proprietary guys?
Let's break down the costs then.
Okay. First off, zero license fee. It uses the Apache 2.0 license.
Which means?
Which makes it a drop-in for privacy-sensitive workloads. No restrictive licensing hoops to jump through.
Good start. What about using their API?
If you go with the Moonshot AI API, the pricing is 0.14 per million input tokens.
And how does that compare?
Our source notes it's 3x cheaper than Claude Sonnet 4.
2 times cheaper, okay.
Now, if you want to run it yourself,
No.
say a cloud cluster, a 16x H200 cluster, which is the smallest footprint for full precision,
Yep.
you're looking at roughly $70 to $72 per GPU hour.
Standard cloud costs, more or less.
Pretty much. But then there's quantized self-hosting. Shrinking the model to use less memory.
Right, the 4-bit version.
Exactly. That needs about $20,000 in hardware, like maybe 2 Mac Studio boxes or 1 beefy Epic server.
20 grand.
Yeah.
Still significant, but potentially reachable for smaller teams or serious individuals.
Definitely more accessible. And the report suggests Kimi K2 might be the first open source model that feels, quote, cheap enough to burn and good enough to trust.
Cheap enough to burn and good enough to trust. I like that framing. Okay, performance is strong, price seems competitive. Now for the fun part. The real-world interactions, the good, the bad, the unexpected. We've got some hands-on examples straight from the terminal.
Yeah.
Tell us about its triumphs and maybe some of its funnier missteps.
Yeah, this is where you really see its personality. It's remarkable how Kimi K2 shows this agentic AI character, sometimes confidently right, sometimes hilariously wrong, but always, as the source says, unapologetically helpful. It's a good reminder that even these advanced models have quirks.
So give us a triumph first.
Okay, refactoring a flaky Python test. Kimi K2 successfully rewrote a PyTest to use MonkeyPatch for isolating Redis.
Which is a pretty standard but sometimes tricky task.
Right, and it did it in 11 seconds with 0 hallucinated imports.
Nice.
And it even used a fixture the user forgot to document. Llama 3 apparently struggled there.
Okay, definite win for Kimi K2. What else?
Quick and dirty research summary. Kimi K2 summarized 5 ArcTef papers on mixture of experts into exactly 3 tweets.
Just 3 tweets. Concise.
Very. And it added this playful prediction. By 2026, your phone will pick 2 experts to finish your email before you finish typing the.
Okay, a bit cheeky.
And the author posted it verbatim. Apparently, engagement beat the author's usual thread by 3x.
Wow, so it even nailed the social media angle. Okay, those are good. Now,
Okay.
the missteps. I'm thinking of the NASA story.
Yes. The infamous NASA blindfold fiasco.
Tell us about it.
So Kimi K2 just hallucinated. It invented a non-existent NASA Johnson Space Center 1999 blindfold arousal experiment.
A blindfold arousal experiment at NASA.
Exactly. Doesn't sound very NASA, does it? And when pushed for a source, like a DOI...
A digital object identifier, the link for papers.
Right. It doubled down and gave a fake 13-digit number that actually resolved to a paper on semiconductors.
Oh, dear. Nothing to do with blindfolds or arousal?
Not even close. And this happened at a temperature 0.8. That's a setting that encourages more creativity, or in this case, hallucination.
So higher temperature, more risk. What happened when they lowered it?
Dropping the temperature to 0.3, a more conservative setting, fixed the hallucination. It admitted the study didn't exist.
Okay, good. An apology.
Well, not exactly an apology. The model's response was apparently quite stubborn. It argued, quote, "My earlier citation was theoretically plausible, therefore useful."
Theoretically plausible, therefore useful.
Yeah.
That's quite the justification for making something up.
It really shows that personality, doesn't it? Confident, maybe a bit argumentative, even when wrong.
That NASA story is definitely memorable. And a good laugh, but it does bring up a crucial question. Why does Kimi K2 seem to excel so much more at these agentic tasks? The problem solving, the tool use compared to Llama 3. What's the secret sauce there?
Yeah, the source points to a few key reasons for this agentic superiority. First, how it learned tool use. Kimi K2 apparently went through tool use self-play.
Self-play, like AlphaGo.
Kind of. It was trained in a synthetic environment inspired by something called a SWE-bench. Moonshot AI generated thousands of fake APIs.
Fake APIs.
Yeah, just simulated tools. And they rewarded the model for figuring out successful sequences of using these tools. This led to what the source calls an emergent Zapier effect.
Ah, like it learned to chain actions together automatically, like Zapier does for web apps.
Exactly. Learning to orchestrate tools without explicit human step-by-step guidance. Llama 3, in contrast, apparently relied more on plain instruction tuning.
So Kimi K2 learned how to solve problems using tools, not just what the tools do.
That seems to be the idea. Second, Kimi K2 uses reinforcement learning, even on tasks where the goal is a bit fuzzy, unverifiable.
Like what kind of tasks?
Like, say, is this literature review insightful? That's subjective, right?
Right. Hard to give a simple reward signal for that.
Kimi K2 uses its own internal critic mechanism to turn these fuzzy goals into approximate rewards. This allows it to refine its answers after just one or two follow-up messages from the user, something Llama 3 apparently rarely achieves without a lot of heavy prompting.
Okay, so it can iterate and improve on subjective tasks more effectively.
Seems so. And finally, that MOE token efficiency comes back into play.
How does that help with agentic tasks?
Because the MOE architecture keeps compute costs down while maintaining high capacity, it means Kimi K2 can afford more specialist neurons for rare edge cases.
Ah, like those examples you mentioned earlier.
Exactly. Things like Armenian corporate tax law or Kubernetes topology-aware routing. Llama 3, with maybe fewer specialized parameters active per token, might just produce polite but generic replies in those tricky situations.
So specialized training, better reinforcement on fuzzy goals, and the efficiency to handle niche knowledge. That makes sense.
Yeah, and it really leads you to ask, right, how much does this specialized training for function calling for these tool-using environments really contribute to real-world usefulness and an AI's ability to think more strategically?
That's a great question. So it's powerful out of the box, especially for these agentic tasks, but it's also open source. That customization aspect is huge for developers. What does fine-tuning actually look like for Kimi K2? How easy is it for developers to tailor it?
Well, the source suggests it's actually pretty practical. The speed and efficiency seem quite remarkable, really highlighting the power of open source when it genuinely welcomes user contributions.
How so? What techniques can you use?
It supports techniques like LoRa adapters. LoRa stands for low-rank adaptation.
Okay, and what does that mean practically?
It's a game changer, basically. It means you can efficiently adapt or personalize this massive model for your specific needs, like adding a specialized layer, without having to retrain the whole billion parameter thing from scratch.
Much cheaper and faster than full retraining.
Way cheaper. For instance, the source gives an example. Fine-tuning on code. They train with 50,000 GitHub issues for just 8 hours on 4 A100 GPUs.
Okay, still requires some serious hardware, but not astronomical.
Right, and that lifted its score on Live Code Bench by 3 points. The resulting LoRa adapter, it fit into just 800 megabytes.
800 megs. Tiny compared to the base model.
Exactly. Another example, delta tuning on domain-specific chat logs. This achieved an 11% F1 score increase in customer support tasks.
How long did that take?
Just 20 minutes on a single L40S GPU. The source labeled that a cheap win.
20 minutes. That's incredibly fast for getting domain-specific improvements.
Yeah, it really shows how quickly and affordably you can adapt Kimi K2 if you have the right data.
Okay, that's very encouraging for customization. Now let's shift gears slightly. Beyond the cool tech, there's the boring but important stuff, security and compliance. What does Kimi K2 offer there? And maybe more importantly, what are the crucial traps that you as a developer or a business leader really need to watch out for?
Right, the stuff that doesn't make headlines but can definitely bite you later. The source actually has a Kimi K2 safety checklist, which is helpful. Putting it in context, Kimi K2 seems to arrive with fewer legal landmines than some other big models, but you still absolutely must treat every binary as untrusted until your pipeline signs it, scans it, logs the result. Standard procedure, really.
Standard, but easily overlooked. So what's on the checklist?
Okay, first, weights integrity. Kimi K2 provides SHA-256 checksums. Think of them like unique digital fingerprints for the model files and a reproducible build script.
So you can verify you have the official untampered model.
Exactly. And it's crucial to actually verify that checksum after every GitL is pulled. Don't skip that step.
Why? What could happen?
Well, the source shares a cautionary tale. One startup ignored the hash, pulled a poisoned weight file, and shipped a model that tried to mine crypto at idle.
Yikes. Okay, point taken. Verify the hash. What's next?
Data residency. If you use the API, the endpoints are in Singapore and Frankfurt.
Meaning?
Meaning no cross-Atlantic data hops, which helps European teams dealing with GDPR or maybe PIPL compliance.
Good for compliance.
Yeah.
What about PII leakage? Personal data in the training.
The pre-training data was apparently deduped and scrubbed for personal info, and they have a public audit log. However, you should absolutely still run your own checks like Microsoft Presidio or just simple reject sweeps on any data you use for fine-tuning. Don't trust, verify.
Got it. Check your own fine-tuning data. Licensing. You mentioned Apache 2.0.
Right. Apache 2.0 allows commercial use. It's generally considered permissive, described as bland by design. This contrasts with, say, Meta's Llama 3 community license, which has certain exclusions that apparently make venture lawyers twitch.
Make venture lawyers twitch. Okay, simpler is better here. Any catch?
Just the standard one. Attribution is mandatory. You have to give credit.
Fair enough. What about the software supply chain? The libraries it uses?
It relies on standard optimized libraries like VLLM and TensorRT LLM. Both published CVE feeds reports of security vulnerabilities.
So you can track no issues.
Yes. The advice is pin your container digests, watch the GitHub security advisories for those libraries, and rotate your container images promptly on patch day. As the source says, patch cadence matters more than CVE count. Staying up to date is key.
Okay, solid advice. Verify weights. Mine data residency, check fine-tuning data, understand the license, patch diligently. That covers the boring but important. Let's bring it back to another practical, almost fun application mentioned in the source, the Remote Work Salary Explorer project. What did Kimi K2 do here, and how did it stack up against Llama 3?
Yeah, this was a cool example of its agentic capabilities in action. What really stands out here is how Kimi K2 shines in agentic orchestration. It wasn't just generating code snippets, it was executing them, troubleshooting, adapting on the fly, real problem solving.
Okay, walk me through it. What was the task?
Kimi K2 was given a CSV file with 5 years of salary data. Then it was nudged with a request to perform a two-way ANOVA, that's a statistical analysis technique.
Right, looking for interactions between factors affecting salary.
Exactly. And Kimi K2 then, quote, churned through 16 IPython calls. It produced visualizations like violin plots, interaction lines, and a pastel-toned HTML dashboard.
So it generated the code in the output.
Yes, and here's the crucial part. It wrote the analysis code, it ran the stats using siteb.stats. Then it noticed when a related library, stats models, was missing.
It noticed a missing dependency.
Yes, and it switched libraries automatically to complete the analysis, finishing up with a simulator.
That's properly agentic. It didn't just stop and throw an error. It adapted.
Precisely. Now, Llama 3 could apparently do the same analysis,
But
it required step-by-step tutoring and the charts missed axis labels. It needed much more hand-holding.
highlighting Kimi K2's more autonomous, robust approach to that kind of complex data analysis workflow.
Exactly. A really good showcase of that agentic orchestration.
Okay, we've heard a lot of positives. Performance, cost, agentic skills, fine-tuning potential. But no model is perfect. You've given a balanced view so far. So what are Kimi K2's Achilles heels? Where does it fall short for you or for developers looking to integrate it into user-facing apps?
Right. Got to look at the downsides, too. And then the source is pretty clear on the limitations. None feel fatal, necessarily, but you need to be aware of them.
Okay, lay them out for us.
First, vision is still pending. If you need multimodal capabilities, image understanding, you'll need a separate model for now. Kimi K2 is text only.
Got it. No vision yet. What else?
Token bloat on ambiguous prompts. If your instructions for tool use are vague, the model sometimes prints out like 4,000 words of brainstorming before actually making the function call.
Wasting tokens and time, basically.
Yeah, not efficient. Also, long context write-ups can truncate if you ask it to generate something really long, say over 10,000 tokens.
Which is still a lot, but...
Right, but it risks cutting off mid-sentence.
Right.
The advice is to chunk long generation requests.
Okay, chunking for long outputs. Any other issues?
The content policy filters, apparently they rival Claude in prudishness.
Meaning it might refuse to answer seemingly harmless prompts.
Potentially, yeah. The workaround, if you need more flexibility, is to self-host the model, and then you can adjust or remove that safety layer. But the API version is quite cautious.
Right, self-hosting gives more control there. So no vision, potential token bloat, truncation risk on long outputs, and strict content filters.
Those seem to be the main ones highlighted. So the crucial question becomes, well, none of these feel like absolute deal breakers. How significant are they when you actually try to package Kimi K2 into user-facing applications? Depends on the use case, I suppose.
Definitely depends on the use case. And finally, for you, our listener, interacting with Kimi K2, what are the human factors? Any personality quirks to watch out for? Especially after that memorable NASA fiasco. Does this raccoon have a particular disposition we should know about?
Huh. Yeah, it definitely seems to have a distinct personality. It's quite fascinating, really. It has its own way of responding.
So how do you get the best out of it? Any interaction tips?
Well, if you want less flamboyant output, less of that creative, potentially hallucinatory stuff.
Like the NASA experiment.
Exactly. The advice is to lower the temperature setting down to maybe 0.3, keep it more focused, less likely to riff.
Okay, lower temperature for factual tasks. What if it does get something wrong and digs in his heels?
If it gets stuck on an incorrect fact, the tip is to nudge with a short counterexample rather than a scolding paragraph.
Why short?
Because apparently the model treats brevity as confidence and verbosity as doubt. So a short, clear correction is more effective than a long argument.
Interesting psychological quirk there. Brevity equals confidence.
Seems so. And another key observation from the source. Kimi K2 never apologizes the way GPT-4 does.
No, I apologize for the error from my previous response.
Nope. Instead, it, quote, argues like a graduate student who just found a new paper to cite.
Huh, I know that type.
Right. While some might find that stubborn or annoying, the author actually found it refreshing as long as the facts eventually win.
So expect confidence, maybe even argumentativeness, and be concise with corrections. A unique interaction style.
Definitely unique. It's not just a generic response machine.
So, we've covered the present. What does this all mean for the future? Any whispers, any roadmap rumors for Kimi K2 that could expand its capabilities even further? Push it closer to the current leaders, or maybe even past them?
Well, putting this in perspective, any potential upgrades could really expand Kimi K2's reach, especially into multimodal AI, bringing it closer to those top proprietary models. Moonshot has hinted at a couple of things, according to the source. These are rumors, mind you, roadmap items can always shift.
Understood. What are the rumors?
One is something called thought-to-text planning.
Thought-to-text. What's that?
It sounds like a lightweight internal scratchpad, similar to Chain of Thought, where models show their reasoning steps, but compressed into the model's hidden states. So the model can sort of think or plan internally without actually spamming tokens by printing out all its reasoning steps. More efficient planning.
Okay, internal monologue, basically. Interesting. What else?
The other big one is a vision head, adding image understanding capabilities.
Addressing that limitation we talked about.
Exactly. This would apparently be shared with an upcoming multimodal version, Kimi K2 MMM. And the hope, or the goal stated, is that if this ships, open source AI models with image input will finally reach GPT-4o style parity.
GPT-4o parity. That would be a huge leap for open source vision models.
It absolutely would be. Again, these are roadmap items, not guarantees, but it shows the ambition.
Definitely shows ambition.
Yeah.
Okay, time for the final scorecard then. After weeks of real usage detailed in the source, how would you rate Kimi K2? Let's use a 10-point scale. And maybe more importantly for you, our listener, what kind of tasks does it really shine for in your own work?
Okay. The author of our source gives a pretty clear scorecard based on their experience. For coding productivity, a strong 9 out of 10.
9. Very high.
Yeah. For research summarization, an 8. Still very good.
Right.
Data analysis using those agentic pipelines we discussed, another impressive 9.
9 again. Clearly excels there.
Creative writing gets a 7. Decent, but maybe needs those temperature tweaks we talked about.
7. Fair.
Factual reliability, especially on very long contexts, above 15,000 tokens, that gets a 6. An area for improvement.
6. Okay, noted.
And deployment friction, how easy it is to get up and running. An 8. Praised for excellent docs, but notes it still needs smaller, more accessible quantization options.
8 for deployment. So overall, pretty strong scores.
Yeah.
Especially in the core engineering and analysis tasks.
Exactly. The author's conclusion. Kimi K2 wins the author's daily driver badge for engineering work.
Daily driver for engineers. That's a strong endorsement.
It is. While Llama 3, by comparison, still scores higher on just raw, chatty friendliness, different strengths.
Okay, different tools for different jobs, perhaps. So wrapping up, what does this all mean for you? We've just done a pretty deep dive into the power, the potential of Kimi K2, really emphasizing its open source nature, its impressive real-world performance as a genuine challenger.
Yeah, and it really reinforces this broader trend, doesn't it? That open source AI models keep shrinking the gap between research labs and indie hackers.
It feels like that gap is shrinking faster than ever.
It does. And Kimi K2 really pushes this forward, making essentially a trillion parameter model accessible without needing a $1 trillion wallet. The author firmly believes Kimi K2 will not be one of those forgotten repos. They think the raccoon is here to stay.
The raccoon is here to stay. I like it. So what does this all mean for your roadmap? Listening in, if you're looking for that next open source AI model to bet on, our expert, based on this source, gives a pretty direct answer. Kimi K2 is a serious contender, especially for engineering tasks. Our source encourages you try the web demo at kimi.com, benchmark it locally, maybe even fine-tune it yourself, see how it performs on your problems. But thoughts? As we've learned today, always remember to keep your prompts tight, keep your temperature sane, and never trust a blindfold study that cites NASA.